Hello, welcome to GP Podcast. So what if I told you that some of the biggest, most important questions of the last 100 years all have the exact same origin story? A single, powerful piece of math that, believe it or not, was born from a really bitter argument. We're going to start with a question that literally kept the world's greatest scientists up at night. I mean, this was a question where the answer would completely change the course of human history. Then, let's look at a question you probably don't even think about, but you rely on every single day. Out of trillions of pages on the internet, how on earth does a search engine find the one thing you need, like, instantly? And finally, we've got a question that sounds, well, kind of trivial, right? Like something you'd argue about at a party. But the answer is anything but simple. And just like the others, its roots go back to the very same, very unexpected place. Because the key to all of this, it's not some modern-day supercomputer algorithm. Nope. It's an intense intellectual showdown that went down in Russia over a century ago, right in the middle of a political firestorm. Let's start right there. So picture this. It's 1905, and Russia is on the brink of revolution. You've got socialist uprisings challenging the Tsar, and that tension, it was everywhere. It even managed to creep into the world of mathematics, which you'd think would be totally objective. On one side of this fight, you have Pavel Nekrasov. People called him the Tsar of probability. He was a deeply religious man who believed that math could actually prove the existence of free will. And on the other side, Andrey Markov, an atheist nicknamed the Furious. He thought Nekrasov was committing a cardinal sin, mixing math with things like God and religion. Their entire argument boiled down to a 200-year-old idea called the law of large numbers, which everyone thought only worked for independent events, like a coin flip, where one toss has zero effect on the next. Markov was absolutely determined to prove Nekrasov wrong, to just demolish his entire argument. And to do that, he had to show that the law of large numbers could work for dependent events too, where what happens next is totally influenced by what just happened. And he found his perfect weapon, not in a physics lab, but in the pages of a famous Russian poem. Okay, this is where it gets really clever. Markov took the first 20,000 letters from the poem Eugene Onegin. First, he proved something every writer kind of feels in their gut. Letters are not random. A vowel is way less likely to come after another vowel. Then he built this simple little predictive machine, a chain, that just modeled the chances of a vowel following a consonant or a consonant following a vowel. And when he ran it, the text it generated eventually settled into the exact same 4357 vowel-to-consonant split as the original poem. Boom. And just like that, he created something totally new, the Markov chain. And its real genius is how simple it is. To predict what's going to happen next, you only need to know what's happening right now. It's like it has amnesia. It has no memory of the past. All that matters is the present moment and where you can go from here. Markov finished his paper with that absolute killer of a line. He had proven his point, completely shattering Nekrasov's argument about free will. But here's the crazy part. At the time, almost nobody cared. Markov himself didn't seem to think it had any practical use. He had no idea his little abstract idea was about to get very, very real. All right, now we're going to jump forward in time. It's 1945. We're inside the top-secret Manhattan Project. Scientists are in a desperate race to build the first atomic bomb, and they are stuck on a problem that is just mind-bogglingly complex. The stakes could not have been higher. We're talking about an explosion equal to 25,000 tons of TNT. And the question they had to answer was this: how much uranium do you need to get a runaway chain reaction? Trying to calculate the path of every single neutron was just impossible. But the answer, as it turns out, was going to come from a pretty strange place. So there's this mathematician, Stanislaw Ulam, and he's recovering from a really serious illness. To stop himself from going crazy with boredom, he starts playing solitaire over and over and over. And he gets obsessed with this question: what are the odds of actually winning a game? Calculating it directly was hopeless, but then he has this flash of genius. What if I don't have to calculate it? What if I could just play hundreds of games and count the wins to get a pretty good guess? So when Ulam shares this idea with his colleague, the legendary John von Neumann, everything just clicks into place. Von Neumann realizes simulation is the key to the whole neutron problem. But there's a big difference. See, in solitaire, every game is a fresh start. They're independent. But neutrons, they're not. A neutron's path depends on where it just was. The events are dependent. So you couldn't just simulate random outcomes. You had to simulate a chain of dependent events. You needed a Markov chain. This new simulation idea was a huge success, but the story of the Markov chain was far from done. So let's jump forward again, this time to the 1990s. The internet is exploding into public life, and it's creating this new kind of chaos. It's like a giant library with millions of books, but no one's invented the card catalog yet.
The first search engines like Yahoo just counted how many times your search term showed up on a page. It was super easy to trick the system. There was no real way to measure quality. And then along came two Stanford students who had a totally different way of looking at the problem.
Their big idea, their breakthrough, was to stop thinking about the web as just a pile of documents. Instead, they saw it as this massive, interconnected network, one giant Markov chain.
Here's how they saw it. A link from one page to another, that's just a transition, a step in the chain. But a link to a page? That's something special. That's a vote of confidence. It's an endorsement. And the more high-quality votes a page got, well, the more important it had to be.
So Larry Page and Sergey Brin created an algorithm they called PageRank. It basically simulated a random surfer who just clicks on links over and over for millions of steps. And the pages where that surfer ended up spending the most time, those were declared the most important. It was an elegant solution that completely solved the quality problem and gave their new company, Google, a massive, massive advantage. And that brings us right up to today. That same simple idea that the next thing that happens depends only on what's happening right now, it's become the foundation of our entire modern world.
Seriously, it's everywhere. From Gmail predicting the next word you're going to type, to scientists modeling how diseases spread, to forecasting the weather. And yeah, most importantly, Markov's work is the direct ancestor of the large language models that are powering this whole AI revolution. It all goes back to a guy trying to win an argument about philosophy.
Which brings us all the way back to that last question. Now we know that a perfect riffle shuffle, where you split the deck and weave the cards together, that takes about 7 shuffles to get random. But what about that clumsy overhand shuffle, where you just kind of move chunks of cards from one hand to the other?
The answer is over 2,000. Yeah, you heard me right. A totally shocking number, and it's the perfect final example of how this weird bit of math can show us these surprising truths about the world. A process that feels random is actually, mathematically, anything but. So, from a dusty argument about philosophy to the atomic bomb, the internet, and modern AI, the Markov chain is just this powerful reminder that the big, abstract debates of today can plant the seeds for the technologies that will define tomorrow. It really makes you wonder, doesn't it? What seemingly pointless arguments are happening right now that are going to completely reshape our world in 100 years. If you like this video, subscribe, leave a like, comment on what you liked most, and share the video. Thanks for watching.